So, now we move on to the next lecture, that is last lecture of last week in this course, that is intelligent diagnostics and risk of AI. Okay. So, why intelligent diagnostics? Because when I was discussing PHM, AI, the diagnostic part was not well covered. So, now have this part A, these two are not connected, but I thought even if we can, time is available, so we can cover it in a limited sense actually. And risk of AI is well known subject. Okay. So, diagnostic, we know that diagnostics operate with if and then rule. So, we have this framework, like first overall if I see how the operator advisory systems are worked, these are planned inputs, and then you have a transient which are processed through artificial neural network. It identifies loss of offside power expert system. So, it because based on the signature it has identified loss of offset power, it could have been LOCA, it could have been there are 14 conditions for which the plant has been trained. Then you have EOP. EOP means emergency operating procedure. Okay. So, class 4 emergency operating procedure is there, and then status normal, you go back to this thing, but status is not normal. So, event based procedures are fired, and then process system normal, then we have one way you go up, if it is so, and then finally safety functions, main EOPs they come into picture, core cooling function, and then accident management, and if it is yes, then you go further up, and then you have track to the normal operation. So, this is where, but we have to understand from here onwards it was a event based procedure. Now, time domain system got stabilized, we have time to do diagnostics, and plant is under shut down. So, there is no hurry. So, event based procedure or symptom based procedure are fired depending on the requirement. Now, diagnostic approaches are come after the identification of, so in sequence it is number 2, risk assessment and management approach for AI intelligent based applications. Okay. The fault tree of a system and event tree of a system, they give us a knowledge base. We can extract the knowledge from there, because we are talking about risk conscious. So, knowledge of risk and whatever comes with that, reliability and all that also tap it, and then expert system. Expert system is nothing but a rule based system. If A is equal to B, B is equal to C, and D is equal to E, then 1. If A is equal to T, so these rules are formed, if and then rule they are called, we'll come to that. So, they operate on rule, and for the complete system diagnostics, rules are formulated, and if in your house there is a power supply, you might sometimes say is it a fuse failure, bulb failure, or any some connection failure. If it is a fire, if it is a spark, we take it on the risk side. If there is a non-availability of power supply, then we take reliability of the power supply. Something expanded version happens, but we always apply if and then rule, even in our routine life actually. So, this fault tree is emergency power supply system fault tree, diesel generator, DGA, DGB, and all those things. So, we have gone to the system level. In fact, when we develop fault tree for knowledge based development for the any intelligent system, we have to go to the sub level, bottom, because it is a deductive approach. We have to go further down till we reach the component level. But it is a good idea to stop somewhere and do a good job, and then replicate the same at the down level also, root cause level also, and then common cause failure and all. Now, common cause failure is very difficult. It happens somewhere from the outside. Flooding event has taken place, common cause failure. High humidity in the area, it could be a common cause. Human factor is like fire happens, it is a common cause. So, these type of events, we have to understand the system which affects from outside of the boundary or inside of any electromagnetic pulse. somebody is doing welding in some area and my system induced a transient, these kind of things. So they are not pre-prod. Actually, they are as you operate the plant and you learn it. That's how they become part of the operation, risk conscious operations management. And yeah, so I have done this actually. Lube oil failure, so I have developed it further to the component pump and all that. And finally, I got this. If I model of this, their failure mode, mechanism, effect, analysis, then I will be able to plug in a good information here for my rule based system to develop. Because if I have to read the fault tree, how it is that emergency power supply failure has occurred. It can happen because of bus failure or DG failure or common cause failure. So this becomes a rule actually. And then if that happens, then further we go. DG failure occurs because of DG1 and DG2 failure. It became another rule for developing a knowledge base in the rule based system. Breaker A failure. I can go down to the breaker. I have given this circle as if I have reached a basic event. If I analyze the breaker, I will get the subcomponent, spring, contacts, alarm, trip, all those things will get, drift in the setting. So those things will get. How deep you want to go into, because deep learning, when we are talking about it, we have to really go to the deeper level to build our intelligent system. So just one example, if and then rules are at the core of diagnostics, and if this part is called antecedent and then this part is called consequences. How antecedent is what? DG1 membership function 0.9 and DG2, that is failure. Membership function is 0.9. That means there is a huge confidence that these two events have happened. Then emergency DG1 check the DG1. It is giving signal to the next module, check module, DG2 check module. If emergency DG1 signal low lube oil pressure 1 kg, so it is going into the specific of performance parameter and the confidence level is 0.8. It is and then lube oil diagnostics. If the DG2, DG breaker status fail, not close membership. So this is just a demonstration of how huge database with thousands of rules and they make, sometimes they make only couple of components. So you can imagine the kind of inference load is there on this particular analysis and all. Fuzzy production rules. So, and these are the crisp rules are there, but we can have fuzzy rules also. Here, this thing confidence level will be replaced by the fuzzy membership function, and that will decide whether this rule should be fired or not fired for the analysis. Now, AI risk management. Since without this subject, we would not have completed our talk on AI because with every good thing, there are flip side also. So, introduction artificial intelligence, AI has numerous advantage. It's a positive consequences, that is benefit. It cannot be counted. They are tremendous, and there is a world over there is a recognition. But the negative or risk or liability consequences, they also will be there. But then, as an academician, we have to talk about it now, and there are efforts going on, at institutional level, national level, and all. The major risk in risk management and mitigation in AI are inspired from conventional risk management. When I was developing this module for AI, I felt there is a lot of at least overlap with the conventional approach, and that will be seen in this slide also. The scope of AI assessment has hardware, software, human, and now you see the paradox. Software as such, the safety of critical system people, especially the nuclear plant and all, they don't take this system software systems with a pinch of salt, and their confidence is they have the traditional hardwire system to back up with the digital system. So software has got a question in a public domain. It might work because system has failed, you can say, but if it is failed in unsafe manner, that is not a good sign in complex engineering system. Now, why I am talking about software is a core part of even AI also. So the complexity of software, complex software handling AI or developing AI, then you can imagine. So this is one thing, and then human. At the outset we say that human is a difficult to model. So human and software, these two makes work on AI risk assessment and modeling little challenging. So the challenges I am pointing out here, the technology though has new promise, and third and top of the it is any new technology has its own mode of failure. So one has to be very careful when we use these systems, especially in risk critical areas, and then anomaly and all are precursor monitoring. They can provide some this thing and structured approach. And now one more additional thing is, earlier we had only safety risk, now we have a security risk. So that means we have to make our system very robust, that they are not available, the coverage should be so high that they are not accessible to harmful effect or deliberate harmful effect. So this is the risk importance that we give it to our AI system. So technology risk. Technology risk is, earlier there was a dependence on human, they are considered intelligent, or they are intelligent of course, and now we are imparting this intelligence to the hardware systems. So there could be surprises, okay. Even if we have a very good aperture, so the AI trained and benchmark validate AI system have a superior intelligence to in certain pockets human intelligence, this AI intelligence will be much more useful, but there will be some areas where humans perform better. So those pockets have to be find out, and you have to have a coverage factor for that, or a safety fallback arrangement should be there. There is a need to look at the coverage factor or completeness of postulation of random failure and deliberate event, that means safety event and security event, and this has to be as complete as possible. New technology, yes, it has got its own surprises, and even though we are excited about this technology, but there has to be some care on using this system, especially again I am repeating in the risk critical areas actually. Now what is our fear? Our fear is how to use it, where to use it. But then we can have lot of we are having experience. Our electronics, we were having ball based technology somewhere 60s and before that. Then we came to the relay based technology, and at every arrow point we had our own apprehension how it will work. And then and then relay based technology was used. Then solid state logic, new component, microchip, with 100 to 150, starting from 15 gates to something like 120,000, and then VLSI, war very large scale integration, and field programmable gate arrays, antifuse and SRAM buys. Antifuse means hardwire, we can see it as a hardwire, and SRAM means software based. So technology we had, and then software, here onwards the software component entered in our hardware domain, and then VLSI, FPGA technology. So and then finally that means some upgradation took place, and now we have in some era where all advanced. This was somewhere in 80s, 90s. Now we are in 2025. A lot of advancement has taken place. So I could have called advancement actually here, and then AI/ML involved deep learning. So here attempt is to replace the human for because if human this system can think like human, we are having a car on road which is operated by AI. We are having so many systems, they are operated by AI, and the confidence is growing. But there is a flip side, as I said, and the risk assessment engineers, they should be very careful about it when they talk. So this is the good side of AI, and the issues we are discussing here, which I while discussing the evaluation of this technology. Now the way we do risk modeling in AI also, we have to induce a lot of initiating events which are possible. It could be anything. It could be hardware related, it could be environmental related, it could be related deliberate attempts like EMI, EMC, although electromagnetic interference, and we have to see there is some phenomena called single event upset, or some radiation environment. If you put some chip, the chip signal will change for a moment and it will come back. we will not be able to do any, and suppose if some action got initiated because of this, then it could have a consequences. So, single event upset is a very important point, especially when FPGA came into existence and we started talking about it. So, now I hope this chip, there is something called hardening. So, we have to give hardening here, so that radiation does not put any consequences on the electronics or AI chip. Now, AI also is coming on the chip, the complete build system. So, VLSI, FPGA, SRAM based. Loss of complete power supply failure, this is very, we are used to, so we can borrow these things, certain events, and we can see how my system behaves and what kind of redundancy, diversity and all we can provide on those. So, identify the control, and now once you identified the way we do for hardware component or plants, we have to do here also. We have to design protection system. Why protection system? Because interruption is acceptable, but unsafe failure are not acceptable. So, bring the AI to safe state, and now finally, so many guidance have been given over here. Each we will discuss, and they are metrics, they are guidance, they are inputs. So, we can think about it. So, what should be the framework? Now, this information, it was a wonderful document, and it was, I am lucky to have hands on this document. It is available in open domain, and this is risk management. Sorry, the document's name is not there here. In AI document, risk management, document is here. National Institute of Standards and Technology is a body, society, or and US Department of Commerce has published a document, NIST AI 1001, Artificial Intelligence Risk Management Framework, year 2000, very recent document, provides valuable insight in direction to risk management of AI systems. So, we are lucky to have a document like this, which is a umbrella which is not remaining limited to plant, but it is trying to see the risk postulation in societal and global ecosystem, and it expands, but the institute, they themselves proactively talking about it. It will be updated periodically as and when more and more information should come. But it talks about what should be done, how it should be done, those things we are missing, and we have to do it. This document has been published in two parts. One is foundation and other one is core profile. I am just winding up in one slide, because it is a, if you want to see this document, you can have it access over here, but the information of our interest is already there in this one. So, what it does at foundation level, a life cycle and key dimension of AI are captured over here, and that start with the design and plan and design, and then second sector is collect, process data information, build and use model, verify, validate, deploy and use, and operate and monitor. We knew these steps, but putting them in perspective is a big thing actually. This is the outer circle, and inner circle, application context. They are related to operate and run. So, they are related. There is a main heading and subheading that are happening here. Collect and process data. So, data and inputs are coming in over here, and then we have build and use. So, this is model specific. Verify the model, build and model, and then task and output, deploy and use. So, this complete, and this is people and planet. Very big umbrella, and trying to address the challenges or development methodology, operation methodology, and the harms also have been designated as harm to our nation, harm to people is harm to our nation, and harm to ecosystem, and definition and ingredients are there for these two. And the challenge to AI risk management includes risk measurement, designation. So, this comes into the next thing, risk prioritization. We have talked about it. AI dimension, one of the interesting part in AI dimension is the context of AI application as shown in figure. So, this is the life cycle of AI has been captured into one dimension. It is very useful for any AI developer we have. And then the last part of this document is core and profile. One more thing, but whatever relevant we are talking about it, this part deals with the outcome and action that to be taken. So here the first element is govern. Govern is at the core. That means policy, legal and regulation. Then map, context driven risk identification. Measure, we do rather we can claim that we are trained in doing that, that is measurement and management. We have discussed all through this lecture how to manage and all that. So this function can be referred to as G3M, govern, and 3 M's are there. G3M, governing strategy. Each function comprises of more than one category. And so I have said govern. Govern has got sub matrix, and then it has got a sub matrix. So that's how it has been organized in the document. Overview. This lecture had two parts. One is a diagnostic part, and second one was AI risk part, and if and then rule, and in overview of NITs. This is a very important pretext in this presentation, and all the AI developer or initiator, they should get hold of this document, and there may be many more documents. So we can have a good practices and a broader umbrella overview understanding before we have our hands on developing AI application. Thank you.